So until this point, we have largely been looking at programs that are, for lack of a better term, more self-contained in the sense that their function is carried out for the most part in the main function and functions that are written alongside main but otherwise don't have much classification. And while for basic usages this is fine, as your programs grow more complex and need more functionality to do bigger things, this can become tedious and tiresome to maintain using this method of organization. So in this lesson, we're going to learn a new way to organize your program and compartmentalize functions and information within your program so as to hopefully better allow for the flow of your program to function better. So if you may remember from Chapter 2, Lesson 3, we had something called a structure, which basically allowed us to put a whole bunch of different variables inside of a box, for example. Basically, we could have an integer or a string, and we could have all these variables associated with each other and access them from a same sort of super variable. And that allowed us to keep track of related information. For example, we kept track of the information of a person. Now, however, that's just for information. What if we expanded the structure's idea to allow functionality as well? And this is where we get the idea of a class, or object-oriented programming. And what a class is basically it's another container, but it allows you to store both variables and whole functions. And you would access them much like the way you would in a structure. You just make sure you just have the class, and you would just access the sub-function or variable that you wanted. However, classes are a bit more complex than that. So, beyond that, I have, in my experience teaching other people, that I have noticed that people don't seem to quite catch on why we use a class to begin with. That can be a little difficult to grasp, so I'm going to try and explain that here. So, let's say we have our main function, right? And so this main function is a scope. You may have seen that in compiler errors. Is that it not only is it a function, but it contains code and it contains variables. So within this main function, we have a class, or in this case, actually, it would be an object because it's a specific instantiation of that class. And then we have the main logic flow of int main, or rather, what you have hard coded into the main function. Now, normally you might just write the entire logic flow into main or into functions around main. But what if you want to be able to call on within a function while in your main logic flow and have it be nicely categorized in something already available for you? So this is where we bring the object into play. So for example, we have, again, the main logic flow. And the main logic flow within main asks an object of class myClass if it can perform some sort of complex calculation. And so the class gets this request and then runs the function, uses internal variables, its own variables. It does its calculations on its own outside of the main logic flow of main. And then, while still in the scope of main, returns the result of that computation. And so you can continue on your logic flow in main. So one of the things that can be helpful when studying object-oriented programming is to look at a more abstract example of what a class could be. And I think in this case, an excellent example would be a person. Because a person is capable of being many things, knowing many things, and doing many things. So we will look at exactly some examples of what that might be. So a person has certain properties. In this case, we'll refer to them as variables because they are essentially the same. They don't perform any function themselves, but they can provide information to other functions. So a person has a certain age. A person has a certain height. A person has a certain gender, hair color, eye color. And while we might think our thoughts are actually a process because we have to think in order to make the thoughts because it's a result of the thinking process, or in other words, from a CS standpoint, it is the return value from our thought function. that these are actually variables of themselves because they themselves do not have any actual functional purpose. They serve functions, but they themselves are not functions. So they are, more in this case, a variable. A person also has certain abilities, things they can do, and these fall into the case of more of functions. For example, they can manipulate objects. We can pick things up. We can change settings on whatever. We can interact with the physical world around us. And so that's an important function. We can think. In order to make those thoughts, we have to have the capability of taking data and then getting thoughts out of what that data might tell us. And we can also communicate with other people. Now, this is incredibly important because it becomes really relevant when we talk more about the specifics of the class paradigm. So keep that in mind. And we can also make friends with other people, which again is also important to understand. One of the things that gets added to the class paradigm beyond just the bin of functions and variables that would be implied from being related to structures is that they have certain access restrictions. Other classes and the main logic flow cannot access certain parts of a class if you don't want them to. And so this gives us the access level of private. Private variables and functions can only be accessed within the class itself. Private can be helpful because and there are many cases where there's a function that you don't want to be available to other classes because there's really no need for anybody else to be calling it other than that class. It's also helpful because if you have a variable that's private, the computer doesn't have to make it available to the whole program. It just has to make it available to that class. So it limits the amount of memory that is needed to hold that variable, which is useful. So with our abstract example of a person's private functions and variables and properties and so forth would be their thoughts. I mean, you could be psychic, but beyond that, there's nobody that can read your thoughts. Nobody else can take you and then read your thoughts straight out of your brain. You have to ask them first. Their feelings, which are on the same level as thoughts, and while those can be read from facial expressions, those are through other functions of your person, and they're not reading the raw brain data that's coming out. Your opinions as well, for the same reasons. And your thought process. Here's an example of a function that's private. Another person can't call your thought process. They can trigger it, but they can't actually directly incite you to start a thought process. And then we have the other access level, which is public. And these are things that other classes and the main logic flow can access. These are the things on the front end of your class that you want other classes in the main logic flow to be able to access. So what these might be which is largely just communicating. But this includes being able to ask what someone's thoughts are, ask what their feelings are, ask what their opinions are, or tell them things that would trigger their thought process, or just other communication. So there's the ability to talk with other people. Speaking is another function that's public, because other people need to be able to hear you speak, so that needs to be accessible. That you can request opinions or thoughts or feelings from other people, like I said. And your expressions are also examples of public, because other people need to be able to read your expressions. And then, of course, your height and other basic, obvious characteristics that you may have are public because they are available to everybody, not just yourself. So with that, we also add a new idea to object-oriented programming. Beyond that gives us a little bit more of a scale between public and private. And so it's not just black and white. You can either access it or you don't. So drawing back to our person abstraction, people have friends, and this is important because when you're with your friends, you are more lenient. You're not as likely to censor yourself, in that you're more likely to be open with your friends because you can trust them more. And so this carries over with the idea of friendship in programming is because this adds another level of access to our list. So of course you have public and private, and your friends can access the public things, but they still can't access the private. But they can access another level called protected, and this would give you, again, greater access to your thoughts, your feelings, and your opinions because you aren't as you trust them more. You aren't as likely to question what they're going to do with what you tell them through that process. You're also going to be more loyal and more respectful to them because they're your friends, and you can trust them more. And finally, there is one more thing that classes allow us to do, and that is inheritance. Where you have a parent class, and you can have a child class that inherits the properties and functions of the parent class. And so you can have some class, and you can have it inherit another class. And so in this case, what we can take from the person idea is that a person has parents, of course. So let's say one person is a child of another, and that the parent has the ability to fly, and because of that, the child inherits that ability to fly. Now, the difference between people and programming is that in programming, child objects inherit everything about all of their parents. They don't just inherit specific traits depending on probability. So let's say the other parent has laser vision, and so the child will also have laser vision. So anything that one of the parents would have, the child has, and it's not just a randomness between the two. And so this can be helpful when you need to access some common function that has already been implemented by a previous class, but you need to expand on that functionality. And so that is where inheritance will come into play. So that is the basics and concepts to classes. Next, we will be looking into the code of all of these functions and ideas.